let me bring up a screenshot that I have here for the first question. All right. So the question is, it's regarding using the signal blocker in a particular application here. So, so the customer emailed in. They want to see the first two signals that show up, and then they want to skip or block the remaining signals until they get the next reversal signal, like so. All right, so we'll work on that today. So, and okay, so let's use this oil chart here. Yeah. And, let's see. All right, I'm gonna have to come up with some signals. So let's see. All right, yeah, I know what I'm gonna build something real simple here, just for the sake of generating signals. And okay, so let me get BloodHound open here, and right, first thing I want to do is put in today's file name. I'll get that in there. All right, so we have our BloodHound system named, and next I'll just start working on the logic tab here. And I need to start a new logic tab. So let's name this here. All right, so we're going to block the first two signals, at least until we get the next opposite signal. Right. So I'm just going to build something real fast to generate a bunch of signals here. And let's see, where am I looking for? There we go, threshold solver. Okay, so I'm going to use this MACD here on the chart. It's kind of a trend filter. I'm just going to throw the MACD in there. And let me just make sure that the settings match what's on my chart. So 12, 26, and 9. Yep, that looks correct. And next, so I'm going to filter out long signals when the MACD is greater than 0. So we could see A for threshold A equals 0. So when we're going to get a long output when the MACD is greater than 0, because A equals 0. And then I'm going to do the opposite for short output. We're going to have short output if the MACD is less than 0, because E also equals 0. Right? So less than E, which is 0, I'm going to get a short output. And if we take a look at the chart, there we go. So as soon as that MACD crosses the 0 line, we switch from short output to long. So that's just going to act as a short and long filter for me. So let's see. So I'm looking to see if the MACD is above or below 0. All right. Filter done. And then I'm just going to generate a quick price reversal signal here. So we're just looking for a price inflection. And that'll generate just a bunch of random signals. So we're going to set the input type to price. There we go. Yeah, so we can see whenever the bars reverse direction, right, we're going to get a signal in that direction. And so next, I will connect those two together. So my signals, my signals in here, and then apply the filter. And so there we go. All right, so there's a bunch of signals like so. Yeah. All right, we have a bunch of signals to work with. And I'll just name this AND node as my test signals there. All right, so here's our test signals to work with. So what we want is we want the first two signals, right? And then we want to block the rest. We want to block the rest of those signals. So whenever the trend changes direction, right, we want the first two signals, and then we want to block the rest. Like so. And then come over here again, we want the first two signals and then block the rest. So to start off with, when you're blocking signals, you're going to use a function node here, and we want the signal blocker. And let's see. There are several videos already up discussing various ways, that you can block signals. Do you want to block the first signal, or I mean, do you want to allow the first signal? Do you want to allow the first three signals? Maybe, maybe you want to allow a third signal or a fourth signal and then block the rest. There already are some workshop videos up there that will do that. So just to let you guys know. And okay, so before we, so the signal, okay, yeah, let me just kind of briefly explain. The signal blocker, it's designed to block only the first signal, and then it allows all the rest through. So the first signal gets through, and the remaining signals are going to be blocked, right? They're going to be blocked for the number of bars that you specify. All right, so when it comes to computers, they need to count stuff. So computers are, great at counting things. So the signal blocker needs to be given some kind of limitation. So do you need to block for only 5 bars, and then, or maybe only need to block signals for 50 bars, or 100 bars, whatever the case may be. So you need some kind of limitation in there for how many bars you want to block for. And then there's these resets here. So these resets give you the ability to stop the blocking before the 100 bars is up. Right. So if I put 100 bars on there and say, something, I could create a reset condition, plug it into the reset node there. You guys will see there's a reset node there. So I could create, some kind of set of solvers and logic and connect it into the reset, and that could be detecting some other condition that says, you reset the signal blocker early. Don't wait for the 100 bars to go by. Let's say only 50 bars go by, and price, some indicator or price does something, and you want the signal blocker to stop blocking signals, so you want to reset it. So you can reset it before this 100 bars is up. So that's what all these reset capabilities are for. Right? And so what we need to do is before we can start using the signal blocker is we need to count up to 2 signals. We need to, determine when do we have these 2 signals, and then start blocking the remaining signals afterwards, right? Because remember, the signal blocker is designed to allow the first one to go through, and then block the remaining signals. So we need to create an allowance here, and so what we're going to need is the signal counter. So we can use the signal counter to count the first 2 signals, and then when the signal counter turns on, then we know it's time to start blocking. So let's get the signal counter working first here. All right, so with the signal counter, we need to figure out, what are we counting? So the default's going to be signals. You can count other things. So you can see non-signal bars. So let's use this diamond here, right? So that would be a non-signal bar, non-signal bar, non-signal bar. So even in between those 2 long signals, right, there's a non-signal bar. So you can count non-signal bars, or you can just count total bars, any number of bars, whatever the case may be. So again, if you want to get more information on the signal counter, there is another video up there that just covers the signal counter all by itself. So let's see. So we want to count 2 signals, and so again, the software needs to know how many bars are we allowed to look back when we're looking for. So when we're looking for the 2 signals to count, how many bars are we allowed to look back? Right. We as people say, we can intuitively say, oh yeah, I'm just counting these 2 bars, but a computer doesn't know that, right? A computer says, well, I'm just going to keep counting. I'm just going to keep looking back, and looking back. So we have to tell the computer, give it some kind of limit, as to when it can stop looking back. So you kind of have to figure out, like, how many bars could go by, in between signals. So let's kind of ignore the long signals in between here, right? These 3 long signals in the middle, just kind of ignore them for now. And so let's say this is our first long signal, and this is our second long signal. You kind of need to figure out what is the maximum span here that your first 2 signals could require. How many bars apart might those 2 signals ever happen at? And so obviously my test signals just fire off all the time. We have a little bit of a span there. So let's look back a little further. Not much of a span there. Let's see, from there, that might be a little wider than the previous span of long signals that we had. It's not too many bars. That looks like it's 10 bars or less. Again, only a few bars apart there. Only a few bars apart. My test signals just generate a ton of signals. So, all right. Let's probably just go with 10. Maybe 10 ought to be fine. So I'll go with 10, and I'll just add 2 extra. So I'll just round it up to 12, or with that, we'll just round it up to 15. So, all right, so we're counting up to 2 signals. Our look back is going to be within 15 bars. The signal threshold 0.8. So just if you're not using fuzzy logic, just keep this where it's at. Just keep the signal threshold where it's at, and it'll match the signals that you see on the chart, right? Because remember, to get these racing stripes, the threshold you know, the output of BloodHound, its threshold is 0.8, right? So you can see the little red line, the real thin red line, and the thin green line. Those are thresholds of 0.8. So you know, when the output exceeds that 0.8 threshold, that's when we're getting the racing stripe. So, you know, we're just going to keep this the same, keep it in line with everything. So let's see. We're not going to have to deal with reset signals, so I'm just going to turn that off. And next, let's deal with the output here. So let's actually take a look here. And so for the output style, instead of using the fuzzy logic, so you can see the fuzzy logic's going to step up on every signal it finds. So here on this bar, let's stretch things out a little bit here. So on this bar, it finds the first signal, and so we get an output of 0.5. Actually, it's going to step back here. So, okay, so here's our first long signal, and you can see the output of the signal counter is 0.5. So it found, what the signal counter did is it found half of our two signals that we're looking for. So that's what that fuzzy logic is. And then when we find the second signal, now it's found all two signals, and so our output is 1. But you know, again, most people aren't using fuzzy logic, so we're just going to put it on digital, like so. Switch it over to digital. So as soon as this second signal is found, there we go. Signal blocker outputs. All right, it's going to output along there as soon as that first signal is found. And let's scroll back here. So here's the first. Remember, here's the first short signal, and then the second short signal, and then we start getting this short output on the second short signal that's found. So let's see. You notice that, yeah, sometimes there are long and shorts at the same time. You know, that's really, I don't think that's going to affect anything, but you know, if we wanted to clean that up, that looks kind of funny to you when we clean it up. We could use a reset here. Let's see, we want input opposite signal. There we go. There we go. So when we get an opposite signal coming into the input, it cleans it up there. All right. So, yeah. So let's take a look at this again. So here's our first long signal, and then here is our second long signal there. All right, so the signal blocker is finding our second long signal. And so what we're going to do is we're going to take this signal blocker, and let's scroll out a little bit there. And we're going to combine this signal blocker with the original signal. So let's take the original signal. Let's port our signal blocker in there. And all right, so we notice that we have let's grab an arrow here. There we go. So the first signal is missing a signal. The second signal is now showing up. So we can't, you know, so here's kind of an instance where you can use the signal counter to, you know, skip the first signal, or, you know, you can use the signal counter in a way to kind of skip skip the first, second, or third signal. You know, whatever you want to count to. You know, so say in your system the first signal or maybe the second signal, you know, aren't typically good signals, and you want to skip them, right? So we could use the signal blocker to skip them. So if you wanted to skip the first two signals and you wanted to start seeing the third signal, we could do something like this. So we can see over here, right, the first two short signals are skipped, and then we see the third one comes through, right? So that's not what we're doing today. So let's just kind of put this back here. And let's see. So actually, yeah, what we want is the opposite. We want the first signal and the second signal to get through. So what we need to do, what we're going to do is, let's take a look at the signal counter again. So you notice how the first signal doesn't have an output and the second one does. So what we're going to do is actually reverse the output of the signal blocker, or we're gonna invert it actually. And let's see. Yeah, there's no. If you'll notice, there's no invert option here on the signal counter. Function nodes typically don't have an invert option, but we do have a invert function node. So we're going to grab that invert function node, plug that in there, and so now if we look at so if we look at the if we look at the output of the invert here, so we do have a long output on that bar. We're missing it on the second bar there. So what we're going to do is we're going to increment the count up to. So we're actually going to count up to 3. And so now this inverter has an output on the first signal and the second signal. And then when it gets to the third signal, then our long output down here, let's just grab this, so we can see our long outputs turn off afterwards. So instead of connecting the signal counter, we're going to connect the signal in, or the inverter in. And now let's take a look. Let's just clean this up a little bit. There. So now let's take a look. Okay, so there's the first long signal and the second long signal, right? Coming through, and then the rest of the long signals are blocked. All right, so let's take a look. Let's take a look at our original signals again. All right, so here's all of the original signals, and so we can see the third, the third, fourth, and fifth long signal are being blocked now. So let's see here. Let's rename this AND node. So okay, there's the first two signals coming out of that. And let's just kind of scan through the chart here. So all right, so our first two short signals are coming through as we had marked. And let's see. So here we go. So this now here's when we're going to start needing the signal blocker now. Let's see. Well, or maybe we can make an adjustment to the signal counter node to block these two signals. But yeah, so here's some more coming through. So we're gonna have to make some adjustments here. But let's just continue on so we can see we're getting the first two long signals coming through, right? And then all the other long signals here were being blocked. And we'll probably maybe find some more long signals coming through. Oh, I guess not. I got cleaned up. Okay. So let's go back. Actually, I guess I'll just delete this arrow here. Let's go back to these short signals here. All right, so let's just mark these bars. All right, so we have some signals that managed to escape through, to sneak through there. And we want to make sure, we want to figure out why these signals here managed to get through, and then from there we can figure out how to block them. So let's minimize this chart again. So let's see. Let's take a look at the original signals here. So yeah, we can see a bunch of signals are coming through. All right. And I'm going to take a look at the signal counter, see what's going on here with the signal counter. And okay, so here we go. We can see in here the signal counter, it lost count, right? It lost count of the 3 signals that it's counting up to. So that's the problem. So maybe just adjusting the look back period here a little higher. Let's go to something like 50. So, all right, so here's our first 2 short signals, and then the signal counter picks up 3 signals that it's counting, and it's continuously able to count these 3 signals until it gets to the long signals there. So yeah, so with that should do it. So now it's right. So we're plugged in our AND node there, and let's take a look at the chart. Right, so we're getting just 2 signals. The first 2 signals. And let's see, I think, yeah, there's no more there, so. First 2 signals. There we go, first 2 signals. All right, first 2 signals, and it appears, yeah, there was only 1 long signal there. And first 2 signals, first 2 shorts, first 2 longs. Looks like there was only 1 short. Yeah, only 1 short in that area. So there we go. Actually, we didn't need the signal blocker in this particular case. Let me get back to my work area here. Here we go. So we were able to just adjust the number of look-back bars here to get the signal counter doing all the work for us. We actually didn't need the signal blocker. So Yeah, so let's see. The key was we set our signal counter to count up to one additional signal beyond what we want to see, right? So, right. So the question was, we to see the first two signals and then block the remaining. So the signal counter, since we're using an AND node and an inverter, the signal counter needed to count actually up to the third signal to get this to work. And then we just had to increase our look back period so that the signal counter would find 3 signals within this look back period. All right, so looking at the screenshot, let's kind of go back to the screenshot here. Let's see. It does kind of, yeah, I guess these signals aren't spaced apart all that much. So looking back 50 bars might work in this particular situation, but if your signals coming in, are really spaced far apart, depending on the spacing of your raw signals coming in. So let's take a look here. So here's the raw signals, right? So my test signals that I generated, they're firing off signals all the time, right? Really close together. So, something a little more practical is your system might be generating signals much further apart from each other, right? And so if your system is generating signals much further apart, then you'll just need to increase this look back period. So, right, that's all it comes down to. So, and also we had a reset. So we did need to use this input opposite signal as our reset there. So what that means is, right, so we got our first 2 long signals, and then as soon as an opposite signal comes in, right, so these short signals would be opposite of the previous long signals. So as soon as this opposite signal comes in, that resets the signal counter. Right? That resets the signal counter. So, and let's see, I think we actually have an example here where, yeah, here we go. So you can see we got 2 shorts, 1 long, and 2 shorts. So in the signal counter, if I turn this off, yeah, if I turn it off, you can see it kind of removed that long and those 2 shorts, right? So it didn't quite work properly. Let's turn that reset back on. There we go. Now we can see all 5 signals there again. So, all right. Well, I think that does it for this question. So, signal counter with an inverter. So I just used the default settings for the inverter. Nothing needed to be changed there. We're just using the inverter purely as an inverter, so I didn't have to adjust anything. So, all right. So, with that, let me take a look at the board, see if there's any questions on this. No, it does not look like I do not see any questions coming up. Well, guys, I guess have a great weekend. Maybe hopefully tomorrow. I'll see you tomorrow in the Blackbird workshop. But if I don't, have a great weekend, and I hope to see you guys next week. Alrighty, bye-bye, guys.